So for the first one, we have f of negative 4. When we see f of negative 4 like that, what it's telling us is to take the negative 4 in the parentheses here, and it goes in for what was in the parentheses, which was x. So in other words, plug negative 4 in for x. So we plug the negative 4 in for x, and now it's just a matter of doing the math. Now in doing the math here, we have to remember the order of operations. Remember PEMDAS? Order of operations. The first thing we do is we do the parentheses. Now the parentheses, in this case, is the absolute value. So we're going to have to do the stuff inside the absolute value first. Then we do any exponents. In this problem, there aren't any exponents to worry about. Then we'll do multiplication and division. Then we'll do addition and subtraction. All right, so in this case then, since I am doing the negative 4 plus 1 next, I'm going to go ahead and do that. That gives me a negative 3. Notice the absolute value bars are still there. So now I'm going to do the absolute value of the negative 3. What is the absolute value of negative 3? 3. Positive 3. Because the absolute value makes whatever number is inside of it positive. But notice you have to do the addition or subtraction first. All right. Now notice that the 2 was sitting out front of the absolute value. When it's written next to it, it's like a number being written next to parentheses. It means to multiply. So we're going to do negative 2 times 3. And then we're going to subtract 3. Now what comes first in the order of operations? The multiplication or the subtraction? Subtraction. Think PEMDAS. P-E-M is next. Multiplication is next. So I do the negative 2 times the 3. Now when doing that, I had you do it without a calculator. So you need to know off the top of your head that a negative times a positive gives you a negative. And that's how I know that it's a negative here. And then 2 times 3 tells us it's 6. Then I do the negative 6 minus 3. That gives us negative 9. Now if you're having trouble doing something like negative 6 minus 3, a great tool to be able to use to do that is envisioning or even writing out a number line. All right, and so then we envision this number line here, and we got 0 sitting in the middle of it. We're starting here at negative 6, so I envision, okay, there's negative 6, and then I'm subtracting 3, which means going down 3 more, because the negatives are to the left and the positives to the right. And so if I go down 6, and then I go down 3 more, that's why it's a negative 9 then for the final answer. All right, then for the second one here, we're again finding out what f of negative 4 is. And so just like the previous one, I'm plugging the negative 4 in for x. There's going to be a lot of similarities between this one and the last one, but I also want you to be aware of the differences. You notice there is a lot of stuff that I made the same about the two equations, but the fact that the absolute value became a squared does mean we address it slightly differently. All right, so the first thing I do is I do parentheses in the order of operations. That means figuring out whatever the inside of the parentheses equals. So negative 4 plus 1, well, once again, that gives us negative 3. Next up in the order of operations, now that I've done the parentheses, is exponents. So now I need to do the exponents. So that means I'm doing negative 3 squared. Now remember, negative 3 squared just means that I'm doing negative 3 times negative 3. What's a negative times a negative? A positive. And then 3 times 3 gives us 9. So that's a positive 9 when we do that then. All right, next up in the order of operations after exponents is multiplication and division. That means I have to do the negative 2 times 9. What's a negative times a positive? Negative, absolutely. And then 2 times 9 is 18. So we end up with f of negative 4 equaling negative 21. That's your final answer. Notice how the work is shown. This is the level of work I'm expecting you to do. I'm expecting to see, first of all, f of negative 4 equals on every line. We're keeping track of what that function notation was, because that function notation is telling us this is the value of f when I plugged in negative 4. That notation helps us keep track of what it is and what we plugged in originally. Makes it a little more precise when we look at the final answer down at the end, because we can just look at it and know what did we plug in and what did we get out. And also in terms of showing the work, yeah, I want to see all these steps. You do one operation, then you show me what that gives you. Then you do the next operation and show me what that gives you, and so on and so forth. So each one is on its own separate line there.